Which of the following statements accurately describes the purpose of random projection in scikit-learn's dimensionality reduction techniques? A. Random projection is used to project high-dimensional data into a lower-dimensional space by randomly generating a projection matrix. B. It preserves the distances and relationships between data points in the original high-dimensional space. C. Random projection is primarily used for noise reduction and feature selection. D. All of the above. Correct. This statement accurately describes the fundamental concept of random projection. It uses a randomly generated projection matrix to map data from a high-dimensional space to a lower-dimensional space. This projection preserves essential information about the data structure. Correct. While random projection doesn't perfectly preserve all distances, it aims to maintain them with a certain degree of accuracy. The Johnson-Lindenstrauss lemma guarantees that distances are preserved within a small distortion bound. The key idea is that the data points in the lower dimensional space are still meaningfully related to each other as they were in the original high-dimensional space, though the relationships are not exactly the same. Correct. Random projection can be used for noise reduction by filtering out certain dimensions that might be heavily influenced by noise. It can also implicitly perform feature selection as the lower dimensional space may highlight more relevant features, effectively discarding less significant ones. Correct. All the previous statements accurately describe aspects of random projection. It's used for dimensionality reduction, preserves distances with some distortion, and can contribute to noise reduction and feature selection. D. All of the above. Dimensionality reduction is the process of reducing the number of random variables or features in a dataset while retaining as much of the relevant information as possible. It's often necessary when dealing with high-dimensional data, as high dimensionality can lead to challenges such as the curse of dimensionality, where algorithms become less effective with increasing dimensions and difficulties in visualization. Example, in a medical dataset, you might have hundreds of features about a patient, including demographic information, lab results, and medical history. Dimensionality reduction techniques can help you identify the most important features for predicting a patient's health outcome, making the data more manageable for analysis and model training. Image recognition reduce image data for efficient classification. Text analysis reduce text data for efficient topic modeling and document clustering. Anomaly detection identify outliers in high-dimensional data. Speeding up machine learning algorithms. A projection matrix is a mathematical tool used to transform data points from one space to another. In random projection, this matrix is generated randomly and used to map data from a high-dimensional space to a lower-dimensional space. Data visualization project high-dimensional data into a lower-dimensional space for easier visualization. Randomized algorithms are algorithms that use randomness to solve problems efficiently. They often provide approximate solutions but can be much faster than deterministic algorithms. Particularly for large datasets, random projection is a type of randomized algorithm, as it relies on the randomness of the projection matrix, finding approximate solutions when exact solutions are computationally expensive. The Johnson-Lindenstrauss lemma is a mathematical result that states that a set of points in a high-dimensional space can be embedded into a much lower dimensional space while preserving pairwise distances between the points up to a small distortion. This lemma provides theoretical justification for the use of random projection. Dimensionality reduction provides mathematical proof that dimensionality reduction can be achieved while preserving distances. Scikit-learn is a popular machine learning library in Python, and its random projection module provides implementations of various random projection methods. These methods include sparse random projection, Gaussian random projection, and Johnson-Lindenstrauss. Dimensionality reduction provides various implementations of random projection methods for use in machine learning projects.